Okay. The DC machines. Okay. So there's most there are two types of DC machine, a generator or in that motor. There are two type of machines in electrical. It's either a generator or a motor. But you see a DC machine. Yeah? The the two the two types of machine is a generator or a motor. Nah? Then the type of DC machine is separately excited machine. Okay. Then number two is self-excited machines. Okay. When we do a calculation, we'll be only doing calculations on this one. Okay. This one you just have to know about, okay, economy. Separately excited simply means that, yes, sorry. If field winding has its own separate what? Source. You know? So in a case like this, if we start a motor, the disadvantage of this is that I'm gonna need two supply. I'm gonna need a supply to supply Ndoni field winding. Then I'm gonna need to supply Ndoni armature separately. Hence Ndoni separately excited. Okay. In case of a generator, okay, okay, I'm only gonna need one supply, Anna, that is supplying that is exciting Ndoni a field winding. Nah? Then the armature will be generating electricity. Isapi i-load yakho most. If it's a generator load yakho, you are gonna connect it with, yeah. Then you're generating from indoni armature. So current is from the armature, then you go load. Then it's self-excited. That's what a separately excited generator means. Okay, we're only just gonna browse it through, ne? Because I was not doing calculations kuzo. But senze calculation kuzo this self-excited machine. Okay, self-excited machine. I'm only gonna show you a shunt series. You know. Yeah, bona. If let's say this machine is a what? Is a motor. Okay. The machine is a general term, na? Xa sithetha like xa sithetha sizi-human beings sonke ne but ke ngoku sishiyana ngantoni i-race ne so it's a general term for meaning is either I'm talking of intoni i-generator or imoto. Yeah. Okay, so hence I'm saying separately excited machine but ke ngoku let's say this machine is a what? It's a motor ne that means I'm putting in a supply ne. Okay, and look at the current flow yahamba njani. I load, I armature, I load yasplitter apha, ibe I armature, ibe I shunt. Okay, what is different from the separately excited is that the armature and field winding are connected to a what? Common source. So you don't need two sources in this case. Uh, let's say if the machine is a generator, notice when I'm saying if the machine is a generator or it's a motor, notice the direction of the current. Because the direction of the current I find for a motor and what? Generator. Because with generator, where are you generating? Achana. Then the current is from the armature here to your supply load. Then you see that as a generator, a self-excited machine, it's supplying its own what? Field winding. Yiloo nto kuthiwa yintoni? Self-excited. Okay. Same goes nakwintoni? Nakwi-series motor. No? Common source in case of a motor. In case of a generator, the armature is supplying its own what? Field winding. So this type of machine are dependent on residual magnetism for operation. Yabo? As windings azibi like sort of like imoto, ne? Imoto has to have a battery. It has to have a battery for biting. Is that but guys starting is generator la ngokwayo kubana, ne? Same case nalapha. Initially, before this machine will operate, they have to have a residual magnetism. So as field winding, kumele zibe nayo magnetism etheni encinci ekhoyo, so that if it is a generator, we can start the generation process. If it is a motor, we can start the motor action process. Okay. So so basically, these two are self what? Excited. Yeah, one is self-excited is divided into shunt, series, and compound. Okay, and compound. Compound is a combination of these two. Okay. So the first thing is the first formula that we're gonna write down. EMF equation of DC machines. Okay. Notice the heading. EMF equation of a what? DC machine. Meaning which this equation that I'm writing now, you can use it for indoni, a generator or indoni, the motor. Na? Applies both for a generator and a motor. Okay. In case of a generator, this is what? Generated what? EMF. Okay, kasithetha nge-generator na. This is a generated EMF. Okay. Xa sithetha ngentoni? Nge-generator. Then in case of a motor has what you call intoni? A back. Yabo. So u-E lona kasithetha ngemoto, sithetha ngentoni? Nge-back EMF. Okay. Because a motor as rotator, ne? As the motor rotates, it is generating electricity. Ne? But the electricity that it is generating is opposing what? The source. Ne? Okay, learn to try and a back EMF. And if you look at this equation is defined in terms of intoni? Construction of the machine. Ne? A motor and a generator are constructed in a similar way. Ana? Okay. Qha kushiyana ngentoni? Operation, na? Okay. So if you look at apha sithetha ngentoni? Nge-poles, sithetha ngentoni? Nge-flux, sithetha ngentoni? Nge-speed, sithetha ngentoni? Because the conductors, amateur what? Amateur conductors, na? Then see type of connection yentoni? Ye-amateur. Is it lamp or wave? Ana? Okay. So you don't see any electrical quantity in this formula except for EMF. Zonke anan what? Electrical. Okay. Then ke ngoku, now that we talked of the general EMF equation, we're gonna go to the specific ones ke ngoku, ne? Okay. Starting the motor, ne? Yabo? This EMF equation is for a motor and is defined using Kirchhoff's laws. No? Hence, every value in this equation is electrical. We have a current, we have a voltage, we have a resistance. No? Okay, this is the in case of a motor, this is the what? Supply voltage. No? Then armature current, then armature circuit resistance, meaning the total resistance of the armature circuit. Okay, so let me talk of a series motor. Okay, okay. So look at where my current is suka from the source was theta the motor. Yeah? The current in a series circuit is the same. Yeah? So IA is equals to IL is equals to bani I series. So kule equation noma ngabeko IL apha noma ngabeko IC or IS. Ana? Okay. Same thing towards the current is what? The same. ORAC is equals to armature circuit resistance. Okay. So if I may go to a shunt motor. Okay. Apple cannot say IN is equals to by IA. Okay, towards upper, we can apply what? Kirchhoff's current law. You see that if you have point current yathini, yes, later, na? IL is equals to IA plus bani I shunt. But now we are concerned about finding bani IA. So if I would write to IA quotient, IA quotient motor is equals to IL minus body I shunt. Okay. That's the EMF equation of DC motor. Let us go to intoni. So immediately that you see poles, you see non-electrical quantity, uzoyisebenzisa mos la formula, yabo? Okay. Lo E umbale ngolu hlobo uyafana nala E umbala ngala formula. Yabo? So you might have to use this equation. Let's say bathi find the number of conductors. Uyazibona uba unayo E but unazo ezi values. Might have to use this equation, then ke ngoku uthathe lo E yomsubstitute apha. Still the same E. Qha ke ngoku le formula, the formula oyisebenzisa kwintoni? Ke motor only. Then for each generator, it's the same equation, but we change what? The sign. Yabo? Okay. So that is the generated EMF. Then OV intoni? The terminal voltage or intoni? Load voltage. OV in this case. It's not the supply because we are not supplying the generator. We are getting power out of a generator. So hence will be a terminal voltage. Okay, then that one is a generated EMF. Okay, let's say we talk of a series generator. And this is where you would connect your load. Then your boy current from the armature because now we are generating. Okay. So I armature is equals to I series equals to I bane I load. Okay. And one. Then let's say we talk of a shunt generator. Current is from the armature because in a generator. So basically, IA shunt generator is equals to IL plus bani. Yeah, what difference? Kwimoto ayimbala njani shunt? Then generator you what? You add. Okay. So now that we have covered this equation, what I want to cover is a power. Power says is the product of voltage and what? Current. But yeah, you must be careful how you go about when it comes to this formula. Yeah, okay, because abantu they like making mistake, a given power is always output what? Power. Unless they tell you it draws this amount of power. Yeah, but so kabesithi it draws, they are specifically telling you that that is input power. If bavele bafaka entoni kilowatt motor, abachongo anything about that power, they just giving you. That means you take it as what? Output power. Okay. Okay. The trick ke ngoku ilapha ne. Masiqale sithethe nge-generator. I-generator iconvecta ntoni kanene? Intoni? Mechanical power to intoni? Okay, so convert mechanical to electrical. Okay, meaning our input is what? Mechanical. Our output is what? Electrical. So andifuna ukubona xa uthetha nge-generator ndikubona ufaka u-P times your u-V times bani? I. Makes sense? Because kaloku input is not electrical, it's what? Mechanical. And in electrotechnics, this is not a mechanical subject, so we don't have a formula for what? Mechanical power, but we manipulate, using efficiency. Manipulate efficiency when ufuna bani? Power out. So u-V times I akabelongi ku-input, ubelonga kwintoni? Output power. V times bani? I bani? I. Na? Then baseke motor. Motor converter electrical to what? Of which is input yami njani? Electrical, na? So UV times IL belonga kwintoni? Kwi-input. So we don't have formula for output power kwintoni? Kwi-motor. Yabo? Okay. Because of ixesha ne ndinjongele I mean ixesha before nibhale ne nibhala nini? 18. Okay. Let us look at just examples there. Example 1.1. Anayo? Nayo na? Aninayo na? Okay. Okay. Namngijonga. Yabo unikwe 6-pole shunt DC what? Okay, uzayifota na? Yeah. Lola's exercise oqala na. After I've just explained, you'll find them very simple na. It is a 6-pole shunt DC what? Motor. Guys, you must note the type of machine. This one is a what? It's a shunt what? Motor. Because taking note of the type of machine will determine zonke ezinto bendikubhalela zona apha. Ana? Like the amateur current, yonke loo nto, ne? Okay. Draws bunny. Which power is that? Output or input? Input, but a draw. Yabo abavelanga ba yeah. Abavelanga bastate nje ipower pha yabo. Bayichazile ne? From a what? A 300 volt supply operating at what? At full load. You must take note of that. And this is at full load. The armature, the shunt and armature resistances are 150 and 0.25 ohms respectively. The armature is what? Lamp wound and rotates at 800 revolves per minute. But calculate the following if the useful flux is what? 35 milliwepers. The magnitude of the what? The magnitude of the back EMF. Okay, so if we are born a Pago's statement, if given, we cannot use the general EMF equation. Why? Because it's a shorter and only the number of what? Armature conductors. Anna? Okay, so what we do is we use the EMF equation for a motor to calculate E, the back EMF by Funan. Okay, if we say about again we can use a power to calculate bani or I load because it's 9 on it, a voltage. And you can also calculate it on it or I shunt because una voltage una resistance kabani ye shunt. And then then you have a load current, you have it on it, shunt current. Guys, the reason we could use that power is because it was input power. Input power motor is what? Electrical. Hence, love V times IL belong to input. Yabo? Yavakala na? Okay. Because in some cases, in most cases, you'll find that they will give you a power and then give you efficiency. You must be aware there is a reason back efficiency. Bafuna or manipulating efficiency to ufumane the power that is what? Electrical. Okay. So we got ubani E using the Kirchhoff's law equation, not the what? The general equation. And number 2 uthi calculate ndoni? Number of conductors. Yambona laa nto bendithetha uba aba E oyi-1 lowa. It doesn't matter uba calculate get general formula or calculate a specific formula. Yabo? So unazo zonke za values ufuna bani? U-Z. Then enye ithi the number of conductors per slot and if there are what? Okay. If okay, so U-Z sifumene bani U-Z? U-610 dona. Let's say we have 617 students and then sibe ne classes ezingaphi? Ezi-100. So kuzongena students ezingaphi per class. So that is a simple division. Uzothi total number of students divided by the total number of what? Classes. Then you get the number of armature conductors per what? Yeah, per class, yeah. Per slot. I was just making example ngalando yoti per class. Then let us look at the second example. The armature of a 6-watt pole. Nayazi masu kakuthethwa ngo P, you divide it by bani? 2. Okay, 20 watt, 25 kilowatt, is that input or output power? output power because bakunikile nje abathongo yabo it's given yabo 500 watt volt and take note of the type of machine bathi yintoni series motor ane is what wave wound and has a total number of 60 amateur slots ne? That is amateur slot, that is not amateur conductors. Okay, we know that motor ne? The output is mechanical, so you cannot use that 25. You cannot do this. This is output power. This is not electrical motor. If it was a generator, then it was gonna be true because in a generator, output power is what? It is electrical. Okay. So the motor operates at full load efficiency of 92%. Okay. While running at what? 1000 revs per minute. Why are they giving you that efficiency? Efficiency is given by what? Power out over what? Times what? 100. Yabona, you can manipulate upper to find money. OPE. Hence I was saying, if magnika power engeyo electrical, you find that they will give you money efficiency. Okay. The resistance of the armature and series field are 0,2 and 0,15 respectively. Calculate the possible number of what? Armature conductors per slot if the useful flux is 45 milliwebers and the brush contact resistance is 0,2. Okay. Okay, I forgot something now. Just something just small lapha ku-series. Guys, no, sorry, let me draw it this side. That's smalanyana thing, nah? Into resistance apha yintoni? Field winding, ane? Then how much? Ane? E is equals to bani, V minus I bani, I R bani, AC. Immediately bathethe brush resistance. That means they don't want you to exclude intoni? Resistance yantoni? Brush. Yabo? So resistance brush, we always take it in series with the what? How much? Yabo? Carbon brushes, the net resistance. So they don't want you to leave out intoni? A resistance, a brush. Yeah, yeah. So a formula yethu izothi, so kasibala RAC sothini ke ngoku? R series plus RB plus R bani RA. What is the voltage drop kwi-brushes? I-voltage drop according to Ohm's law is given by what? Voltage times what? Resistance. Sorry, current times resistance. What is current flow kwi-brushes? Current flow kwi-brush is always, let's say voltage drop ye-brush. The current flow kwi-brushes is always the armature current. Ayitshintshi loo nto because ii-brushes must zizo zikonektha i-armature ne-circuit. So i-current eflow kwi-brushes yintoni? Armature current. So i-voltage across ii-brushes is what? IA, R bani? RB. Yabo? Hence ke ngoku this equation ibizoba so mos V minus ne I plus i-voltage drop yantoni? Ye-brush, of which is i-voltage drop ye-brush nayo ngubani? Ngu-IA R bani B. Yabo. Is still common factor bani. Common factor wo IA. So hence you can just you can just add bani or RP. Okay. Okay, na? Okay, because there are cases where they don't want you to ignore what the brush contact resistance. So base test calculator only number of armature conductors per slot. That means mele siqale sifumane bani uZ na. Okay, so thina siye safuna input power because sifuna usebenzisa which equation? This specific equation. To find bani u-E qala na. Because it's shorter bani or E. Notice that formula. V is equals to IA bhaliwe na. E is equals to V minus IA bani RA na minus I bani IA R series minus bani RP. This is the simplified version of what? That equation. Because the voltage drops Anna? Okay. The term must be applied to noni or Kirchhoff's law to come up with this equation. So can we simplify the equation? E V. What is the common factor there? Negative I bani A R bani. I yonke le nto sithe thina sithatha as bani RA C. Okay. So ayifumana uZ, you also wamfumana u-E. Then you use E to find bani uZ. Then now you can calculate the number of conductors, armature conductors per slot. No? I'm doing like this because of time. No? Okay, let us look at Indoni. It talk again. Guys, kasithetha a talk, sithetha nto. Sithetha a motor. Why would you want to calculate the torque generator? Because a torque generator depends on what is driving what is spinning the armature or low engine or yabo. But the torque motor is determined by electrical values as well. Yabo, you wouldn't want to calculate the torque for a generator. Yabo, a torque generator you can manage it yourself. Yes, okay. If ndifuna le torque ndizothenga i-engine, let's say ispinwa i-engine, i-engine eproducer le torque qha, no calculations there. Yabo kwemoto, i-torque yemoto is determined by how much voltage, how much current do we yabo put in. So kasithetha nge-torque sithetha nge-speed. The topic is about motors. Torque and speed control. Thetha yintoni? Nge-motors only. Because we can manually control speed santoni the generator. If unesipinisa so ndifuna ispine fast, yabo, I manually control that. But when we control ke ngoku speed semoto, we control it electrical, anitsho? Okay. So we are talking of torque equation of a DC motor. Why is torque important? No? The torque is important to the application of the motor. Yeah? You cannot take this motor that is spinning this fan and say, okay, ngizothatha le motor ispinisa le fan drive locomotive. Does it make sense, ne? Because this is finisher into ethini engekho heavy. But a motor that will be driving a locomotive, a motor that needs a huge amount of what? Torque. Yabo? Or a motor a cranes. A motor a cranes would need, let's say, depending on the imanye phakamisa za containers sindala. Udinga a motor that has what? Higher torque. Yeah, amandla, enamandla. Okay. I-torque na-speed asithini? Asifani. Think of imoto. Yeah. Imoto, i-gear 5 has low torque but high what? High speed. So hence ka unyuka iqhina, you have to gear what? Down. Because wena ngoku unyuka iqhina udinga more torque, udinga more amandla. Yabo? Same thing nala. I-torque na-speed are not the same. So a torque equation is given by IA, armature current, flux, poles, Z over bani, over C. Okay. So let us look at the example 1.3. Thank you. It a 4-pole what? DC motor has a lamp wound what? Armature with 6 conductors per what? Per slot. The motor develops a torque of what? 90 Newton meter. Nah? When 30 amps flow through its what? Armature. That is the armature ndoni? Armature current. Nah? For a useful flux per pole of 40 milliwebers, calculate the number of what? Of armature slots. Okay, in order for me, because what I'm given then, I'm given the number of conductors per slot, of which is I have 6 conductors. So I have 6 conductors per what? Slot. Ana? Bona bafuna the number of what? Slots. Okay? That means for me to be able to find the number of slots, I have to know the total number of what? Of conductors. Ana? Then can ke ngoku mna ndisolve ntoni? Le ratio. Le ratio mos conductors per slot, sorry, Z per slot is given by uz total over bani? Number of slots. So I have number of conductors per what? Per slot. If I can find bani? Uz, I can calculate what? The slot. You understand, na? Okay. So into siyenzayo pha. So siqale calculate bani? Uz using what? The torque equation. Yeah. Then ke ngoku sinayo ntoni? uz, which is the total number of slots. Yeah. Niyambona number of slots per your number of slots is given by bani? total number of conductors, because you just now playing around with this equation. Z per slot ne, is equals to Z over slot. When ufuna ubani slot, so the slot is given by Z over Z per slot. Ne understand? Okay, Nicho can understand. Then the next thing we're gonna do now is speed control. We're gonna jump kancinci i-amateur reaction sophinde sibuyele. Okay, I think that is what the author of the book should have done after seyititsha le nto. Bekumele uqale nge-speed control. Page 45, but I'm only gonna write first. Speed control of DC motors. So we want to do speed control calculations and that is a motor. So the formula any speed inye siyaziyo ne, which formula is that? E is equals to what? 2p 60. If le nto sifuna uyicalculate nansiya, okay, so let us make it subject of the formula. That is all. Okay, but you see, on this equation, it shows that I can change the back EMF to change it on speed. I can change the type of connection to change it on speed, which will change one, we'll see. Or I can change the number of poles, or I can change the flux, or I can change one. All that. Okay, thinking now, I wouldn't want to change ubani, C, or change ubani, P, or change ubani, Z to control the speed. Because loo nto izothetha uba every time ndifuna utshintsha ispeed sale moto mele ndithini? Ndidisassemblish. I must disassemble it. It's either I remove number of poles, or it's either I add number of poles, or it's either I remove number of armature conductors, or it's either I add number of what? Is that convenient? That is not convenient. Yabo? Okay. Because every time I have to change the speed of this motor, I have to disconnect it from the supply, then change these things. Okay, so we'll see. What's 60? C P 2P Z. We can take them as what? As constant for a given what? Motor. Okay, so the convenient way to vary speed is changing what? Let me put it like this equation. Okay, this is K A. I can change it on a flux, or I can change it on back EMF. Lo K umele on constant, But now let's take a motor under two conditions, Okay, what do I mean? the motor ibine-back EMF engaka na K and ibirana kwispeed esingaka ne ibine-flux engakanani engaka. So that is the what? First equation. Then ke ngoku we change intoni back EMF. Now it's man E2. Okay, yena stays the same because okay not constant. Then you run on the speed. Then the flux was this amount. That is equation money 2. So if we divide equation 1 and equation money 2, we get E1 over E2 K N1 flux 1 K N money N2 flux money. Hence the K is what? Cancel. Niyayibona masla equation lesiyisebenzisa kuntoni? Speed control. Okay. Then let us look at the one for a torque. We just wrote the equation for a torque. Pen and paper. Then we say T is equals to 0.318 IA plus Z over C. Ibinje. Okay. Yabona naphasi nazo constant. Yeah. Okay, forgot nje P. I-constant zam kule equation ngubani? Z P and bani and C. Okay, so T is what? Equals to K, and K standing for bani those constant. I bani IA bani flux, but if we're gonna take a motor with that had a torque engaka, initially, then armature current was this amount, then the flux was this amount. Oh, now, yes, thank you. No 0, comma bani 3801 9 constant. Okay, thank you. Okay, then first condition, then it talk yangaka. Then you divide the two equations, you get T1 over bani, T2 is equals to bani, flux 1, IA1 over flux 2, IA bani 2. Sorry. Guys, do you see that in case in case of speed, speed is inversely proportional to a flux, because okay, if you look at this equation, E flux and you divide your flux, you see that a flux is speed is inversely proportional to flux, whereas the torque is directly proportional to flux, meaning which at high speed you get what? Low what? Torque. You understand? At high speed, because at high speed that means a flux has to be what? Low. Then when speed is done. At high speed we get what? Low torque. Then at low speed we get what? High torque, because the flux is high. Okay. So there are different methods to controlling speed, but we're gonna control the speed using by changing the amount of flux. Good calculations. we change the amount of flux. Okay, let's say we want to increase, speed. Okay, to increase speed, I have to reduce what? Flux, then what? Speed increases. So if I want to reduce flux, because stating coils, electromagnets, field windings, also electromagnets, coils, I can decrease it on it. A field what? Field current. Field current will lead to a decrease in field current will lead to a decrease in what? Field. Okay, so how do I do that? Mandale ngeshunt. Upper guys, we will be dealing with E series and shunt calculation for speed control now. This is your normal your shunt circuit, nah? Okay. Okay. If we want to decrease the speed, I will have to reduce the current flow to shunt winding. How do you reduce the current? You add resistance. Immediately now, our question is there's a day resistance in series with the shunt field winding. You know that they are reducing what? Speed. So N1 would be less than bunny. You're sorry, they are increasing that? Yes, they are increasing the speed. N1 will be great. Your N2 will be greater than bunny. N1. They are increasing what? The speed. Because by them adding the resistor there, they are reducing a field current. By them reducing a field current, meaning they are reducing field strength. Go reduce a field strength speed is setting. But you are also affecting it talk your anything. Yes. Yeah. So this is the circuit to increase speed of shunt what? Shunt mode. Yeah. So let us go for a series motor. We are increasing speed. Okay, this is a normal circuit for a series what? Series mode. Guys, if I want to increase the speed, how can I reduce the current flow up? Current and in full reduce the current that is flowing we field winding only. How can I do that? I connect a resistance in what? In parallel. So I am diverting this current, the total current xa ifika apha I'm diverting it. Yabo? By me diverting i-total current, that means the current ihamba kwintoni kwi-field winding itheni iyadecrease. So if i-current ihamba kwi-field winding iyadecreaser, i-field strength iyadecreaser, then ispeed siyathini yabo. You can take pictures for this one. Okay, this circuit zothini so increase intoni ispeed ezi, enye ye-shunt enye yintoni ye-series. Now let's say we want to decrease intoni the speed. Okay, there's only one way to decrease the speed. Connect intoni i-resistance in what series with what how much qha ayikho enye yabo. So let's say it's a shunt, decrease the speed, I connect immediately, I connect a resistance in series with the armature. I have basically reduced intoni speed yabo. R bani Rx la Rx benimbala izolo yabo i-circuit banjani. So series same thing, I connect a resistance in series with intoni armature. Then I have reduced intoni the speed. Now the question papers if onina sijonge yona, jonge i-question ethetha nge-speed control abe noba yiphi. Niye namanage uyifumana leya izolo ngela. Okay, singenzi yona ke yonke la question. November bani 2022. We're looking at November 2020 bani. Oh, crap. Okay, kuvela 2020 bani nijonge ku-app. Okay, hello. of guys, particular question. Cala zenithumelele yona na. Abayithumele pha egroupini. Yeah, basenze sonke. Batsho nge-calculations la kakhulu ne. If unombuzo mhlawumbi kwi-theory lotsho. Okay. Kuthiwa phana the resistance of the armature current of a 250 volt shunt motor is what? 0.2 ohms. And its full load speed is what? 1000 revs per minute. Okay. So ke sinikwe i-resistance yentoni ye-armature, which is bani 0.2 ohms. Ana yabona abasinikanga intoni i-resistance yentoni ye-shunt. Okay, in most cases why they don't do that is because probably they given you intoni armature current, because remember you would need to calculate intoni i-shunt current, ana then thereafter ubale ntoni bani IA. So you would need intoni a resistance ezinani ye-shunt, but it's not given. So surely they have given us intoni armature current. Yeah. Okay. I-voltage ubani supply voltage u-2 na the 250 na 250, and its full load what speed is bani? So N1 Emma at what? Full load. So basically guys, the circuit is on is okay. It calculate the resistance required in series with the armature to reduce the speed with full load torque to bani 800 revs per minute. The full load armature is bani 50 amps. Why sizothenga ngu-A1 lowa? Because i-value ka-A1 bani initially siyathi bani full load, because itshilo ithe 1000, ithe full load speed bani 1000 revs per what minute. Loo nto ndisithi ngubani for A1, because it's still at what full load, which is bani 50 amps. Ana okay, bathi i-torque ne bathini nge-torque with full load torque. uT1 naye was at full what? Full load. Ana that means xa besithi no-T2 kubani ku-full load torque, that means uT1 no-T2 bayathini bayalingana, because abatshongo, because bebezothi mhlawumbi 80% of the full load torque, then yayazi ngoba okay 0.8, or mhlawumbi bathi 150 of the full load torque. Like 150 divided by 100. See, yeah, okay. So let us draw the second circuit. Yeah, well, the circuit is to reduce speed. This circuit when carbon draw zone. Connect a resistance in series with the what? Armature. There we go. Okay. So apha ke ngosifuna bani? U-RE. Your RX, sorry. U-RX singamfumana ubani? RAC2. Yabo? U-RAC1 yena ngubani? RAC1 is equal to bani? RA, because we didn't add anything to the armature circuit. But now we added something. So RAC1 akazofana no RAC bani? 2. RAC2 yena bani? RX plus bani? RA. Yeah. So I need RAC2. Okay. I can find it using this equation VIA2 RAC2. Okay. And we know that if i-torque yathini iyalingana, then the IA1 no IA2 bayathini bayalingana. Okay, but let us not always justify that, because ndicinga ntoni? Ndicinga okay, zingenzeka ukuthi i-torque ziyathini ziyalingana. Okay, but i-flux ithini ayilingani, yabo? But of which is in this case i-flux yathini iyalingana, because kusazoflowa intoni i-current eyi-1p kwi-armature. We didn't add anything. We also kwi-field winding. We didn't add or remove anything kwi-field winding. In most cases, kwi-shunt motor, i-flux itheni iyalingana because of that. Because the shunt field current is not dependent on the what? Armature current. Yabo? But in case of a series motor, it's series field current ixhomekeke kuntoni? Armature current, because ziyalingana zonke. But lena it's not dependent on them. So we can say if flux is what? Is equal. Since the flux now is equal, then the torque now is equal. We can say IA2 is equal to bani 50 amps. Okay. Wazocancelisha lena icancelisha ibe ngu-1, then sibe nobani sibe no 50 apha oyedwa, then we cross multiply zobona uba sisazofumana bani u-50 amps. Guys, usually when they make a statement about the torque is to help you find bani bani I2. London they will make statement about the torque, because we are udinga bani IA2 to get bani E2, for example. Yabo, but ke ngosidinga u-E2 ne, but u-E2 asizumcalculator le formula ne, because asimazi u-RAC bani 2. Sizombala ngo obvious eziyasithe ziyakhanzilishana, no? Okay. And in most cases, kwi-series motor ne azikhansilishani ezi ziyi-two, because i-field current ixhomeke kuntoni? Armature current. So into uye uyenze uthi i-1 ibani i-2, then in place of i-flux ubeka wena intoni? Series what? Field current. Okay. Same goes for a torque. A torque must not flux nine. T2 I series 1. Yiloo nto uye ubone kubani obani IA1 bani squared. Why would they do that? It's because mhlambi kwicase yokuqala entoni? Remember, IA I series bayathini? Bayalingana. So if you multiplying into eziyi-2 ezilinganayo, you can put intoni? A squared. Yeah? Okay. So I series 1. This is for a series motor, no? With series motor, ne? You only assume flux 1 is equals to flux 2. Xa bethe it's what? Circle. Assume that the field cores are what? Circulated. Then you can assume that your flux 1 or flux 2 are equal with none with series motor. If I must make a statement in place of flux of ntoni, a field current wena. Okay. Let us find E1. Yeah? E1 is given by, you can find E1 because we have N1, N2. We want or E2. E1 is given by VIA1 RAC1. Current of 50, then your resistance 0, 2. Ban E1 go 240 volts. And we have calculated bani E1 now IA2 as now voltage. So we just have to calculate bani RAC2. So which is E2 bani. Yo, have I calculated E2 or E1 non E2. So you know bani 240 over E2 N1 bani 1000 and 800 bani E2 240 times 800 over 1000 bani E2 go 192 points. Okay, now we have E2. Sorry, then I jump at that side. 192 250 minus 50 RAC2. So basically, guys, I have to transpose. I'm making one RAC2 subject of the formula. RAC2 is equals to 192 minus 250 divided by negative 50. So I transpose that 250 that side, then I divide by negative 50. But RAC2 is 0.9 ohms. Okay. Now I can come and substitute RAC2P per because I know RA. So 0.96 is equals to RX plus 0.2. Rx is equals to 0.96 minus 0.2. Or 0.76 ohms. Injalo mas. Ma'am. Nyayibona na? Okay. There is a question. 1 point bani. Okay, ithini esinye statement esilandelayo. Ngoba bare RAC2 qha. Ayiyo kanjalo kaloku mele bathe bafuna the resistance required in what? In series. Yabo. Bhalwe ngumntu imemo na. Yabo. So akayigqibanga yena uphele phi? RAC yena ubale intoni? I-total resistance yantoni? Amateur circuit. But i-question ithi ucela usibalele uba how much resistance must you add required in what? In series. Or ungazibhala zoyi-2 ke. Ithe how much resistance required in series na? Yeah. Which is Rx. Bafuna Rx. Abatanga calculate the resistance of the armature, the new resistance of the armature circuit. So akayigqibezelanga ke ngoku. Ithini enye question? 4 point. Okay, what is the difference now? The difference now, IA bani 1 is no longer equals to bani IA 2 because it talk nazo thini tshintshile na. So that means T2 is equals to bani 0.5 T1, and I've said it Nati. The reason they will make a statement about the talk is to help you find bani or IA bani 2. Okay. So must calculate to IA2 ohm cha. T1 over T2 is equals to, if fluxes must cancellation ne? IA1, IA bani, IA2. And it's balanga za cancellation. The corner. But the cancellation T1 over 0, bani, 5 T1. So I've expressed ubani what T2 in terms of bani T1. Yeah, okay, so that I can be able to have one unknown. Okay, then kubani 50 yeah? IA bani IA2 othi bayathini T1 baya cancellation. Yambona uba IA2 is 50 times bani 0.5, which is IA2 kubani ngu 25 bani times bathe bona bafuna ntoni? Speed. That means, guys, E2 is no longer bani 192 because the current kaloku lena le itheni tshintshileyo. So mele sibale E2 omtsha before ke ngoku sizoyocalculate ntoni? Speed. So niyabona kweli cala? Yabona? Sorry. E2 is 250 minus bani minus 25, then the resistance bani 0.96. Okay, bani E2 226 volts, and then E1 over bani E2 N1 over bani and 2 flux must cancellation, okay. E1 ubani saying low one 240, then E2 226, N1 saying low one bafuna N2 ohms. Okay, So basically N2, we cross multiply, N2 would be 1000 times 226 and divided by bani 240 bani N2 904 revs per minute. Okay. Yeah, ikhona ne? Okay, there's one mistake na. Tina, we did a carry over. If you look at, sorry, if you look at that question, that means 4.1.1, we treat it different from 4.1.2. So basically, bekumele sisebenzise bani? O 0, bani? 2. Bekumele siyekile leya resistance. I-equation kabani? Ka 1.4.2. Okay. Then 1.4.1, then being 1.4 point bani? 0.2. Yeah. Uh, well, what I'm saying, that yaqaphela u-RAC2, ana? Okay. RAC2 nanko, ne? Which was calculated gobe sifinda la ntoni la RX. Okay. So equation iyonke yeyiphi? Lena le bekunikeza values. But equation yokuqala ibithe i-torque yalingana. Yabo? Calculate i-resistance required in series. Yabo? So question 2 yena uthe i-torque is what? Halved. Must calculate a-speed esani? Esitsha. So basically masingayisebenzisi le value, yabo, base assume that uba the circuit ke ngoku ku 4 point bani ku 1.4.2 isenje ya, yabo. So we treat the questions separate, yabo. So now what I did by me putting that the 0.96, I've carried over from 1.4 point bani 0.1 instead of uba ndiqale ngabusha, yabo. So hence basifake bani o 0.2 basingathi hayi ku-addwe i-resistance basibuyele back to the original question, yabo. That is the difference. So i-2 wethu ubani ke ngoku if sithi ngu-0.2 lowa i-2 ngubani obusathetha itheni the effect of reaction doesn't have any relevance. Amateur reaction, it doesn't have any relevance as a statement. Unless it strong effects of the amateur reaction. Let us go to from top or because we have to start from the top upper. we don't start from where we left off. We don't start from where we left off. Can we find the effects of the amateur reaction? Adverse effects of amateur reaction in case of a motor. That's page 21. Adverse effects of amateur reaction, they lead to the increase of voltage between what? Commutator segments. This in turn leads to sparking between what? Segments and the brushes. Yeah, but it doesn't have any relevance to what we are doing here. Yeah, but because amateur reaction, it causes a sparking at the brushes. I don't know why they mentioned that. But it's not because of that. It's because, okay, each question, yeah, let's say, a question, man, 1.4, Anna? No, 1 point, uqala kubuzwe le, point 1. Then buzwa, point 2. Okay. So now what I did in the you carry over from where you left off to the next what? Question. And you treat each question separate, but e values is this 1.4. Yeah. So e2 utheng bani? 245. So let's suppose take 245. So fumana bani? 10, 20. That's per minute. Then the thing notice along the nakwezinye imemo. Okay, question. You don't carry over like this. It is? Right. Yeah. Don't carry overs like this. Carry over from the bottom. Okay. Unless, for sure, unless you are told from Bani for 1.4.1, then you carry over from 1.4.1. The actual must questions. Guys, they take carry over from what you calculated. Okay. Then let us do 1.5. But me again because as come coverage, the compose is yeah. Let me check something. So the speed control, guys, is okay. Kalani shutele yeah. Mandifuna ukwenza into ene-series then sizoqhubeka. Okay. Page 57.